Hi and welcome. So in the last video we have seen what is app service plan. And now let's talk about serverless computing. So serverless is the most trending word these days, and at the same time it is the most misleading terms as well. So when somebody first time hear about this word, the first thing that comes to their mind is something which do not require server at all, and which is wrong. And I personally feel it is the wrong name that we have given for this architecture in computing, and it is a wrong interpretation that serverless computing do not require servers at all. They do, but it is abstracted from the developers, and cloud providers actually take care of all the servers, global scaling and other aspects, so that the team can focus more on the core of the business and the revenue generation. I read this quote, and which is really good, which says the essence of the serverless trend is the absence of the server concept during software development. So you might have seen during daily Scrum meetings, people are discussing about the problems which is not core of the business, and you might end up having discussion about servers are having some problems and something is not working there, and this was not expected that you should spend your time on such activities for your business. And that is where serverless jumps in, and it helps you in solving this problem where you are not worrying about the servers at all. You are just focusing on the code part, and cloud providers will handle the server part and your global scaling and all those things. So all these things are taken care by the cloud providers. Now let's take a real-time example of how things have changed over the years. Suppose you want to go from point A to point B, and which requires a few hours to travel. And now there are different ways which can help you achieve this and travel from point A to point B. And first, let's say you own a car and drive yourself from point A to point B. The second option you have is that you rent a car for a day and travel from point A to point B. And now the third option is you go by sharing a car with somebody else, which is the most effective option you have. So now all these three options serve your purpose of going from point A to point B. Now we need to understand here that suppose something happens to a car, then who is gonna repair that and maintain that? So in first case you have to do all the maintenance of your car, but in other two cases the owner will do it, and you are just worrying about and you are just focusing on going from point A to point B. And now if we relate this to a cloud computing, so let's see what does it mean with respect to this example. So it's like if you owning a car is as good as owning all those bare metal servers for your computing needs, and renting a car is as good as using a VPS for your application, which is nothing but a virtual private server, or you can call it you are actually renting a VM for that. And the third and the most cost-effective option of sharing a car is as good as using a serverless in cloud computing, which needs a server but somebody else is the owner of it. Now we all know to travel from point A to point B, we have multiple options, and all those options need a car, whether you own it or somebody else own it. Server is similar to your car. In all computing methods, there is a server, but sometimes you manage it or sometimes somebody else manage it. Hence, if now you hear a word serverless, do not assume that you don't need a server for your computing needs. So, why do we need serverless computing? What are the benefits of using serverless computing? So, first is that the increased developer velocity. So as we saw that serverless computing helps us focus on the core of the business, and The developers will actually focus on developing your application and do not worry about the infrastructure, which lets a developer focus on that, and it will definitely increase the velocity. And as you are actually worrying about only the code part, so and infrastructure is taken care by cloud providers and the infrastructure or the global scaling. So in this case, it will definitely increase the team performance, and you can roll out your product features efficiently and fast as your velocity is increased. So you are actually focusing on that part. So it will definitely increase the performance, and it will definitely improve the organization impact, because as you are rolling out your features fast, your velocity has increased, so it will definitely be a good factor for your organization, and it will definitely improve the impact of your organization. And the most importantly, the cost benefits, it is the most cost effective option you have, because you are not at all managing anything as far as the infrastructure is concerned. So let's take a look at some graph which helps us understand that cost benefit part. So you can see based on this graph that how you are going to pay for the upfront cost, which is actually for the traditional servers if you use, and whereas if you go serverless, so you are actually paying for only the compute needs that are getting used. But in case of traditional server, so you are actually paying upfront for the servers which are not used yet, or which may be used in future, or which may not be used. So that is the benefit of using the serverless and the pay as you go model with the serverless computing. So now how we can implement serverless architecture in case of Azure. So there are different ways that you can implement. So I have seen many people think of serverless only for the Azure functions, and Azure functions are actually serverless. So yes, that is one case, but you can implement serverless by different means. So these are the three example that I have given here for your computing needs, that you can go serverless. So first is AKS, Azure Kubernetes Service. Second is Azure Function and the App Service as well. So in case of App Service, we have seen that how we can scale out and scale in um, based on some predefined condition that we set. So as your computing needs increase, so you are adding more nodes and you are scaling out your application so that you can serve your customers. So there are different ways that you can achieve. So these are the three basic computing needs that you can use for implementing serverless. Now let's take a look at the serverless architecture example. So this is basically an example of scalable e-commerce web app. How we have implemented serverless computing in this case. So now based on the diagram, you can see that in the first step, user accesses the web app in browser and signs in using the multi-factor authentication. And in the second step, it is using CDN. So CDN is basically a content delivery network which is used to store your static resources, so that it is like a caching mechanism where you can pull out the resources effectively, so that user has a good experience. So those kind of static resources that are shown on your website, that you can store on CDN. So assuming that part, so in the second step, browser pulls static resources such as images from your Azure CDN. And in the third case, user now searches for a particular product and queries the SQL database. So now we have used Azure SQL database. So in the fourth step, based on the user search query, a website pulls out product catalog from the database, and assuming that we have a SQL database for the different data, and now if we need any product catalog related images, then those are not stored in the SQL database, but those are stored in the separate blob storage. So blob storage is a service from Azure to store your non-structured data. So Now we are using blob storage to store the catalog images, the product images that we have. And in the fifth step, you can see that web app pulls the product images from the blob storage. And for the caching purposes, we are using Redis cache. So in the sixth step, page output is actually cached in Azure cache for Redis for better performance, assuming that it is the first time search. And now the final step is that user submits the order and the order is placed in the queue. We are using a queue storage. You can use a service bus as well. So now there is a function, Azure function, that is actually listening to queue storage. So based on that, we can say that it is a queue triggered function. And now in the final step, once the message is picked up from the queue storage, so it will makes the payment and the third party, and record it will record the payment in the SQL database in the catalog. So that is how the flow of the particular web app is. And now based on this particular diagram, we can say that we have implemented serverless, because you can see there is a web app and there is a function as well. So as we discussed, in there is a different way we can achieve serverless computing, but in case of web app, we have scaling out, scaling in feature, which we can use. So based on that, we can go serverless by using that feature. We can set the predefined condition for scaling out and scaling in, and Azure function is itself inbuilt serverless, so we don't need to manually go and set some kind of a condition that we do in a web app. So there are different ways how you can achieve serverless computing in web app and function, but ultimately you can go serverless by both of these methods. So both the services serve our purpose of serverless, and that's how you can go serverless with this e-commerce web app. So that's all about this introduction of serverless, and in the next videos we are going to see what is Azure function. Thank you.